So as mentioned, I'm representing UFlex. UFlex, as you would all know, is one of the largest multinational packaging materials and solution conglomerate based out of India. We are operating in almost about 150 odd countries. In terms of our product sales, we are in terms of our manufacturing capabilities, we are there in almost about 10 odd countries, and we represent the entire all the verticals of the packaging value chain. I mean, be it any vertical you name it, we are there across all the other all the verticals. And our product portfolios, our customer base, you name it, and we have it. A couple of them being P&G, PepsiCo, Coke, Amcor, name it, and we have the customers. So basically, at UFlex, not just now or not just in recent times, but almost about a decade ago, when we kind of framed the organizational values statement, that we have got 6 values of the organization, and almost about a decade ago, sustainability was one of our values that we kind of agreed on at that particular point in time. So what I'm trying to say is, for UFlex, sustainability is a way of life, is a culture around here, and it is not just something which is being done right now because of regulatory frameworks, so on and so forth. So having said that, I'll just go ahead and take you through the basic approach that we are having with respect to this particular aspect of sustainability. So our sustainability solution, or our approach towards sustainability, is based on 3 key pillars: source reduction, source substitution, and biodegradability. So each of the 3 pillars are important, and a sustainable future or a sustainable solution would only come because of the cumulative impact of the successful approach in all of these 3 pillars. I mean, one of the pillars doing damn well, the others not doing so well, may not result in the desired output. So each of the 3 pillars have to fire all cylinders for us to kind of move into a much more sustainable future. So we'll start with the first one, which is source reduction. Very, very important, and we've been doing this for quite some time now, is how do we kind of look at the waste which is being generated in our packaging plant. So the entire waste which is being generated in our packaging plants across all locations is through the process that I've depicted out here. Is through shredding, compacting, compatibilizers, and through various extrusion processes, we are able to convert 100% of the MLP. 100% of the MLP we're able to convert into granulates, and these granulates are then repurposed into various applications like road building, like horticulture, like plastic furnitures, like furnitures, benches, so on and so forth. So 100% of the MLP that we kind of the waste that we kind of generate in our plant is through this particular process repurposed and converted into granulates. If we go a little beyond, if the entire country gets into this kind of a mode, then we have the potential as a kind of a country to kind of prevent carbon emission to the tune of almost about 1.5 million tons of carbon dioxide. So one of the first steps that we are doing is we are practicing what we are preaching. So this waste collection, whatever we generate, gets into this particular mode. So this is one way of source reduction that we are kind of looking at. The source of waste being reduced. Second is, again, a similar pillar. I mean, we are still talking about this first pillar itself. So how we are kind of, this waste collection goes through the process of, shredding and incineration, and whatever heat we kind of generate, is being used for our plant operations. So this is again another important way of reducing dependency on fossil fuels for running plant operations. So this again, as mentioned, this has a huge potential with respect to reduction in the carbon footprint. This is a work in progress, fairly at an advanced stage. Very soon, some of our plants will get into this mode where the heat being generated after incinerating the waste is being reused and repurposed for running plant operations. Product down gauging. So what we just mentioned in the earlier couple of slides was how we are looking at the sustainability from a process perspective. So what are the changes in the processes that we are looking at, that we have kind of brought around, which leads us to a much more sustainable outcome. Now we are looking at what are the changes. We are looking at the product from the product side, which is helping us further our goals towards sustainability. So wherever possible, down gauging of new generation polymers without compromising on barrier and mechanical properties is what we have very successfully done and has been used in various packaging material. I will just take you through some of the areas where this is kind of happened. So again, product down gauging, one of the important parts is we are also looking at a better decal utilization, which results in less energy usage and better quality product. This again has the potential of reducing carbon dioxide, as I've mentioned in the figures. Product reengineering, this is what I was talking about, and you have an example on the extreme right hand side where the existing we have reduced the micronage, from 30 to 25 without compromising on barrier properties, and this has resulted in a lesser usage of plastics in the product. This has resulted in the product being much more amenable towards recycling and towards other things. So this is a live example, as I was mentioning, how we have now looked at the product size with respect to re-engineering and evolving towards a product which is much more better from a sustainable perspective. Yet another example where we have reduced the micronage of the product from 18 to 12. This has resulted in a better usage, lesser usage of fossil material, and of course, much more amenable, much more progressive towards recycling and chemical decomposition. So what I mentioned right now was about source reduction. Now we will look at source substitution. So as I mentioned, all the pillars are important. So this is yet another important pillar which will take us towards a sustainable kind of solution. So when we are looking at source reduction, these are the three areas where we are looking at. These are the three sources that are there, and in each of these source areas, how we are looking at source reduction. So one is substituting the non-sustainable structures, substituting virgin with recycled content, and of course, looking at the last circle, that I kind of just mentioned. So one of the pioneering products, which is made by our flex plants in Kentucky, Poland, and Mexico, is this particular product, which is 100% PCR polymer content, which has got 100% PCR polymer content. A classic example where an entire product is kind of developed and built basis 100% PCR polymer content. This particular film, Asclepius film, represents a near 75% reduction in carbon footprint versus virgin BOPETs. So this is a tried, tested, internationally accepted, and a successful product with respect to sustainability and of course lowering carbon footprint. Yet another example within our country where almost up to 40% PCR laminate, post-consumer recycled laminate, used in these PET oblique PE products. So 40% PCR laminate is already being used in the products which are being sold, which are being used by our customers, and this product is finally getting into the marketplace. So up to 40% PCR laminate is used in this kind of product. Yet another application where up to 40% PCRP is used in shrink applications. Now these are definitely, these are the quick wins, but definitely an important area. So these were quick wins, and we have been able to address them also very quickly. And this is a very simple example where we are looking at a 40% PCRP for shrink application, and this is already in use in all of our plants. Foil substitution, a very important element of foil substitution is, now we are looking at, in foil substitution, we are first addressing aluminum foil area, because aluminum is one thing which is very difficult from a sustainability perspective, from a recycling perspective. So you would have seen that, aluminum foil has been replaced by ultra high barrier met films with respect to this particular thing, without, again, as I'm mentioning, compromising on any of the barrier properties or any of the mechanical properties of the end product. So this is again absolutely in use and well institutionalized with respect to our product portfolio. Monopolymer based substitute. So this is again an area where we are looking at source substitution, and monopolymer substitution of multi-polymer structures with monopolymer structures has huge advantages with respect to sustainability. So here the example in the earlier slide, the example in this particular slide, where by resorting to mono PE based structure without compromising on any of the properties, in fact coming up with better properties, has resulted in a much sensible output with respect to the end product and its reusage and recycling. Again, examples of two products where the monopolymer and laminate usage has resulted in advantages to us. More of them coming up here. More of them coming out here. These are big bags, 20 kg rice bags, where the substitution has happened with the mono PE in the mono PE kind of format. So and these are available in the market. Some of us would have also used these kind of products. Most importantly, I mean, we all have pets at our home, and again, the entire range of pet product packaging has been substituted with monopolymer PP based packaging material, and these products would be there in almost every second, third, fourth, fifth household. And a classic example where substitution with a monopolymer PP based product has resulted in a much better environment, not only for us but for these dear pets as well. Again, substitution of less sustainable input. This is again a part of that pillar of source reduction. So usage of inks. Now inks, a lot of inks have a huge potential either ways, both ways. So how we are kind of replacing less sustainable inputs with more sustainable inputs is use of non-toluene, non-ketone inks. So increasingly in our product portfolio, we have increasing the usage of non-toluene, non-ketone inks. We are moving quite swiftly and surely towards usage of water-based inks, energy curing, and of course flexo printing, which uses much less heat and results towards less consumption of fossil fuels. Use of CNG and PNG for heating. So, and this has a potential at a national level by to reduce carbon emission by almost about 0.0325 per ton per year. And I'm proud to say that, in our organization, we have almost in our particularly plant in Noida, packaging plant in Noida, we are almost using about 30 to 40% PNG. For our plant operations, and then gradually, once the supply improves, once our processes get adapted to this particular change, we will kind of move on to this particular mode. So you would see in all the things that we have spoken about, in all our approaches that we have spoken about, be it product, be it processes, we have to a large extent adopted them, a large extent modified our internal working apparatus to kind of ensure that we as an organization, not only in India and across the globe, move towards towards a sustainable kind of future. Just a statistic, but a very important statistics. So at UFlex, you would see that all our efforts, and I kind of mentioned that we have been into it for the last almost about a decade. So all our efforts have now begun to see some impact, some outcome, with respect to the carbon footprint. So this you would see had been stagnant till about 2019, and then gradually it's dipping. So as I mentioned, this is a process of evolution. Will take some time before we kind of institutionalize this thing, and then we would see the benefits coming on a much regular and a much positive way. And last but not the least important is biodegradability. I think this is one particular approach which can be a game changer, which should be a game changer. So we are looking at uncollected waste and of course aerobic biodegradable enzymatic waste solution under ambient conditions is what we are working on. We have already developed a solution. We have already developed a solution which is biodegradable in soil environment and under ambient conditions. So we are already quite ahead in terms of developing this particular thing. I'll show you one example as well. And more importantly, this is also in conformance with ISO 17556 of PWM and to be read along with the EPR guidelines. So this is also one of the approaches that ISO 17556 talks about. So we are very much ahead with respect to this particular product. And then once we have the SOPs which kind of certify that this particular product of ours satisfies all the condition of ISO 17556, this could be a game changer for the entire industry. And as you would see here, as I mentioned, we'll be talking about one product where we're looking at enzyme embedded during the process of manufacturing, and how this kind of the end of life happens, under inside the soil under ambient conditions. So as far as this particular 17556 is concerned, it talks about 10%. 10% biodegradation within the first 90 days. And if that result can be extrapolated and it results in 90% biodegradation at the end of 2 years, then this product gets certified as biodegradable under ambient conditions under the soil. And if this happens, this certainly is going to be the plastics industry probably kind of gets into a new genre. So we could call it the plastic 2.0 or plastic 3.0. If these kind of if this particular sees the light of the day. So that's a small capsule on small but definitely very relevant and impactful capsule on what approaches we are kind of following at UFlex, how it has helped us, in terms of furthering the national goal towards creating a sustainable product portfolio, how it's helping us to kind of reduce the carbon emissions. And I'm very proud to say that, as I mentioned, that our approach started almost about few decades ago. And very proud to mention that in the year 1995, UFlex became the first company in the world to recycle mixed plastic waste, earning us a reputation and recognition at the Davos Recycle Forum. So as early as 1995, we became the first company in the world to recycle mixed plastic waste, and it got us an international recognition at the Davos Forum. We've also got quite a few national recognitions as well with respect to these efforts of ours, in the area of sustainability. I would sincerely urge and request members who are keen on this particular concept, on this particular process, to look up our website, www.uflexltd.com for more details. And I would personally be happy to respond to any questions that anybody would have. You could send us those questions over email, and I would be really happy and delighted to kind of respond to all that. Thank you everyone. Thank you everyone for the time, and I hope this is of interest to all of us. Thank you everyone.
Yes, definitely, Manas. We are here to discuss sustainability, and thank you for all the sharing. A lot of takeaways for us, and I'd hope in a forthcoming panel discussion, we will break them down further. Thank you once again.
Thank you very much. Thanks a lot.